7.6 is the last section in Unit 7. If you're thinking about what I added to Unit 7, 7.5 and 7.6 does not come from your textbook. It comes from other books. Believe it or not, we use 7.5 and 7.6 from the textbook that you see behind my head, the pre-calculus textbook. Okay? We teach it in an AM and AMA at this point. It is now being added to Math 2 Honors to show you how else you can use sine, cosine on some triangles that are not right triangles. The only two laws that you can use on triangles that are not right triangles is the law of cosines and in 7.5 the law of sines. Everything else has to be a right triangle. Pythagorean theorem uses right triangles, and so does SOHCAHTOA. Okay? So this is the second law that can be used on any triangle. It can be used when given side, 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 or side, angle, side. These two values are different than the law of sines. Law of sines, you had to have angle, angle, side. You had to have an angle and what was across from it. You had to have an angle and what was across from it as well to set up your proportions. Now for the law of cosines, we don't need that. We need the included angle. That's what we need. This are two sides. Let me write this in red just so we know. Two sides and the included angle. What does that mean? That means that if you're dealing with a triangle, and it doesn't matter which triangle we're talking about, triangle A, B, C, okay? If you have two sides, just like we talked about before, where little a was across from big A, little c was across from big C, and little b was across from big B. If you're given two sides, let's say B and C, you have to have angle A to use the law of cosines. It has to be the included angle between the two sides you're given. If you're given a little and little c, it has to be big B. If you look at these three formulas, each formula on their own, if I'm given little b and little c, I can use it in big A, then I can use it to find little a. You can use two sides and the included angle to find the missing side. That's what we're doing with the law of cosines. There are three different formulas because I don't know which one they're going to give you and which one you're going to need. But in my mind, I memorized the red one only, and I use the red one, and I don't worry about which one's little a, which one's little b, which one's little c. All I remember is these two sides, same two sides, the angle that's between the two sides, I can find the third side. It will work every single time if you just memorize only one of these formulas. I'll show you what I mean as we do a problem down below. This is how we're going to find a missing side. Finding a missing angle, we're going to use these values and take the inverse cosine. These formulas are equivalent to each other. And in order to explain to you how they got these formulas, I would have to teach you a lot more from trigonometry, but I'm not going to. Instead, I'm going to say, here's a formula, it works, it's been proven, I could prove it to you, but you wouldn't understand the proof unless you knew trig identity that we're going to talk about later on, which is like sine squared of theta plus cosine squared of theta equals 1, which is a whole nother lecture, and I don't want to get into that. Okay? So, this formula is going to be used to find a side. This formula is going to be used to find an angle. With that being said, I'm going to walk you through how to set up a problem. We'll do 1 to 2 together, and then you'll get a chance to do your worksheet. Okay? Here are your examples. If you want to do them on the worksheet, you are welcome to do so. Or if you want to do it in the notes, you can do that as well. We're going to go to number 6 first. Number 6 says, find all missing sides and angles of triangle ABC. So what that lets me know is I'm going to see, can I use the law of sines? Let's just test this first. I have an angle. Do I have what's across from it? Nope. I have a side. Do I have the angle across from it? No. I have a side. Do I have the angle across from it? No. You would have more than one unknown if you were to try to use the law of sines. The law of sines does not work here. The law of sines does not work here because you're not given the starting information that you were given in those problems. Angle, angle, side, angle, and so on. You're given side, angle, side. Because you're given side, angle, side, this is perfect for the law of cosines. So I'm going to set this up. What I can find is the side across from the angle I'm given. I can find little a first. The formula I'm going to use, I have memorized, and you will need to learn how to memorize it. It goes like this. What side are you missing? Equals the square root of, and this should remind you of the Pythagorean theorem at this point. If you're trying to find little a, you're going to use little b squared plus, what's the other one we haven't used yet? Little c squared. And then the pattern goes, that's the Pythagorean part, minus 2, first one, b, second one, c, that they're multiplying each other, times the law of cosines of your included angle. The angle better be across from whatever letter this is. If this is little a, then I better be using big A for this problem to work. That's the formula I'm going to use. I know the pattern of those three formulas. Now I'm just going to start plugging some things in here. Little a will equal the square root of. It doesn't matter what little b is, but it's going to go 7 squared. Plus little c is 9 squared minus 2 times 7 times 9 times the cosine of 35 degrees in parentheses. Notice that you're square rooting this whole thing. I am going to recommend to you that when you plug this into your calculator, you put the whole thing in and use a calculator that you can see, did I punch it in correctly? If you're not punching it in correctly, you'll never get the right answer. So, I want you to see, I'm going to take my calculator, I'll turn the little light on here. I'm going to press on, I'm going to press the square root button. I have my square root first. 7 squared plus 9 squared. Minus 2 times 7 times 9 times cosine of 35, end of parenthesis. Now I just want you to look. I went fast. But what I like about this calculator, if you are not using a calculator where you can see what you punched in, you might need to upgrade. I said that to a student in first period today. You might want to upgrade because look at all my things. Am I square rooting the whole group? 7 squared plus 9 squared. Does it match? Minus 2 times 7 times 9 times the cosine. Let me see. I have to keep pressing right. Of 35 degrees. And then I press equals. I can see, did I punch in exactly what I had written? And does this answer make sense? This is the smallest angle. Is that going to be the smallest side? Yeah. If it does not say, please round to the nearest tenth. Now I'm looking at this answer, the nearest tenth place. 5.1? Nope, it rounds up a little bit. It's about 5.2. Okay, there's my first missing side. Now I need to find an angle. If you wanted to, you could jump to the law of sines now if you wanted to. I'm not going to. I'm going to use the law of cosines again just to show you. Okay? Let's say I wanted to find angle B next. Okay? I'm going to find angle B. I know the formula. I'm going to hope that you know the formula as well. The formula for angle B. Same sort of pattern. It's the law of cosines, but we're going to find out what that angle is. We're going to use the inverse cosine. Cosine to the -1 of. When you are using angle B, the only letter that really matters where it is little b. If it's big B, then I better have little b squared as the negative one. That's what's important for this formula. If I have angle B, little b better be negative right there. The other two letters, a squared plus c squared, you can mix those up if you wanted to. But what matters is that b squared is being subtracted from that numerator in this problem over 2ac. That's the formula I'm going to use. Do you notice that I didn't go back to my paper because I have it memorized? I'm going to expect you to memorize these formulas. I'm not going to give them to you. If you don't have the law of sines memorized, that's an easy one. But the law of cosines is a little bit more complicated. After you do several of them, you'll see the pattern, and hopefully it will come naturally to you. Okay, so let's plug some things in. Inverse cosine of little a is the 5.2. Even though I have 5.2 there, I am going to, in my calculator, leave 5.175 in my calculator as I do the calculations. It will help me to be a little bit more accurate. Okay? Plus little c minus little b squared over, I don't know why I did that, 2 times first number times the second number, end of parenthesis. The number one mistakes that students make are that they do not use parentheses correctly, or they forget order of operations when you're punching things into your calculator. So make sure you're punching this thing in exactly as you see it on your piece of paper. Also, make sure you're writing down what you're punching into your calculator so that you can get the most amount of partial credit if you make a mistake. So going to this, turning my light back on so you can see. I'm going to press inverse cosine. I do recommend using the fraction button. That way you can take your last answer, because my calculator still remembers the last answer that I had. I'm not going to retype in 5.175. I'm just going to press the answer button. It's going to take my last answer, all 9 decimal places, and it's going to square it. That's going to save me a little bit of time. Plus 9 squared minus 7 squared. Go to the denominator. 2 times the answer times 9, parenthesis, end of parentheses, so that I don't get an error. Now when I'm double checking, I have to know that the previous answer was the 5.75. That way I don't have to type that all in. What's nice about that is that my calculator has an ANS button, which means it'll take your previous answer and plug it into this formula. It's helpful. Equals. And hopefully you learned something on that one today. A little shortcut. Angle B is going to be about 50 point rounds 9 degrees. There is our second answer, 50.9 degrees. Now at this point, you have your little a, you have your little b. The only thing that you need to find is little c. I would recommend you subtract from 180. So I would do something along the lines of 180 minus the 50.9 minus the 35 to find angle C. And since I have this already in my calculator, I'm going to do 180 minus my answer, minus 35, and my calculator says 94.1 degrees. This plus this, 145 plus the 35 adds up to 180. It makes sense. I've used the law of cosines to find the missing side, and I use the law of cosines to find the missing angles. So the hard part for most of you will be, how do I memorize that formula? It's a pattern. It's just like the Pythagorean theorem. There's a squared, and then there's always a negative, and like, you'll see. Okay, last one, last example, and then I'm going to give you some time to do your work. This time we don't have a picture. We have little a, little b, little c. Those are three side lengths. So we're going to need to find some angles. I'm going to recommend that you always find the biggest angle first. The only reason I say that is because if you find the biggest angle first, if it's obtuse, it will help you if you jump to the law of sines. How do I know which is the biggest angle? The biggest side is always across from the biggest angle. So I'm going to find angle B first. Without looking at your notes, the first thing I'm going to do to find angle B, the first part of my formula is tell the person you're sitting next to what the first thing you're going to use is. Oh, I heard lots of wrong answers. The first thing, this is the law of cosines. In our formula, we are finding an angle, so we should be using an inverse cosine function. Most of you, what I heard were people talking about what's going to go in the parentheses. Don't forget, law of cosines has a cosine in it. Now, there's going to be a numerator. Angle B, that lets us know the most important thing of what's going to be negative at the end of our numerator. Angle B, what goes at the end of our numerator that is negative? Tell the person you're sitting next to. Which means now you know what the other two letters need to be. In the denominator, whatever your first two letters were, you just double it. But you only have 2 times A times C. It's not squared in the denominator. And that's your formula. We came up with it, hopefully, from memory, and now we just plug some things in. I'll go a little bit quicker this time. 18 squared plus 13 squared minus 28 squared over 2 times 18 times 13. If you are not practicing punching this into your calculator, I would recommend that you practice punching it in, because that's half the battle. Looking for those squares. And I usually always end with a parenthesis so I don't get an error. Sometimes you might. Your biggest angle I'm getting that angle B is 128.4 degrees. You could jump to the law of sines if you would like, now that you have this obtuse angle. Or I could use the law of cosines again, and because you need the practice, let's use the law of cosines again to find another angle. I'll probably find the second biggest angle, which is angle A. I'm going to go much quicker this time. Angle A. I'm going to use the formula, the inverse cosine of. The most important thing if I'm trying to find angle A is what's negative? Little a squared. That means b squared plus c squared is positive, and you'll use two of those in the denominator, but you don't square them down there. Let's plug in some numbers. B squared, 28 squared, plus c squared, 13 squared, minus a squared, minus 18 squared over 2 times 28 times 13. And then I'm going to take that and plug it into my calculator. $30.2. And then at this point, for angle C, I would just add these two together and subtract from 180. So I'm going to take 128.4 plus 30.2 and subtract that from 180, which comes out to be 21.4 degrees. I'm going to end your notes right there.